Hi, this is Frances Ringwood here for Infrastructure News. Today for our CPD on Demand video, we're going to speak to Dr. Pieter Crous from consulting engineering firm Smec South Africa about water demand management. So I'm going to get straight into the questions. The first is, where does water demand management fall within Smec's larger service offering, and what professional disciplines do you bring together as part of your total service package?
Sure. Thank you for the opportunity. Water demand management, I'm very passionate about water and specifically the management of water. Smec South Africa forms part of the Smec group, who have a partnership with Sabana Jurong, and we're globally about 13,000 employees or staff in over 40 countries, over 100 offices, and we water demand management falls within the management services function group here at Smec. So we look at, other than water demand management, we also look at asset management, city management, we look at social development programs, and we also look at smart city solutions and GIS solutions. Water demand management takes into account the entire water life cycle, from planning, design, construction, supervision, as well as the asset management and operational requirements of the infrastructure. Okay. So it really brings it all together for us.
So typically, how do you work with municipalities? Do they put these sorts of services out to tender, or do you pitch management services? How does that partnership come together?
Yeah, so typically it's based on our relationships with government sectors, and based on tender procurement processes. So it's either within the strategic planning stages of the non-revenue water demand management processes, where the water service authorities are in the process of understanding what their requirements are, and then also in the implementation of water demand management strategies. So there we'd look at implementing the infrastructure needed to reduce their water losses and manage their demand.
Great, thank you. My next question is, why is it important to integrate technical, social and business requirements for successful demand management?
Yeah, sure. I think the whole of South Africa understands that water is life, and without it our cities would not function, our industries wouldn't function. So it's important to understand that the social context, the economic context within which water is provided, and then balancing that with the technical requirements of the infrastructure. For me, the water value chain starts at the source, so whether that's a dam, and then the infrastructure component, so the bulk and reticulation networks, and then ultimately it comes down to the consumer and their consumer behaviors and requirements, water requirements, whether it's a residential customer or a business or an industry. So I think it's important to look at that entire value chain at the end of the day and really integrate each of those together, without which you're not going to often get a return on the investment in water demand management.
You were saying to me earlier, before the spot started, about how you have to have an appropriately priced technology. You have to look at the right technology for a certain situation, because if you have some madly overpriced thing for an area where it's not appropriate, then that just wastes taxpayers' money ultimately, and it's not going to do the job.
Absolutely. In the water sector, the water value chain, there's so many different stakeholders, components, technologies available. You can't just say that this solution will work everywhere, but you have to really understand what the water service authority's capabilities are, what the requirements are within the cities or towns or even the rural areas, and plan accordingly.
Okay, thanks. And my next question is, why is water demand management a crucial discipline for South Africa's socio-economic development?
Yeah, okay, again, just looking through the water value chain, starting at the source. South Africa is a water-stressed country. We saw that last year with the droughts. The coastal areas are still going through droughts, and it really has a strain on our resources, on our society, on the industries as well. I think the whole country has felt it. But we know this and we understand this, and we go through these cycles, drought periods. So from a source component, it's important, it's critical to manage our infrastructure. If we go down through the distribution networks, installing new infrastructure is very capital intensive. It doesn't happen overnight, it takes time, it requires planning. So it's important to also understand what the capabilities are. The current capabilities of the infrastructure are not just in terms of the design specifications or the proposed design outputs, but look at what the infrastructure is actually doing now so that you can plan accordingly into the future. And then just looking at the last one, the consumers, there it's important to consider the trends of urbanization and what that's going to have on our cities. We understand that globally urbanization is taking place, and it's true for Africa and South Africa. And our cities' infrastructure is going to be under severe strain going forward, as well as our resources. So it's important. Yeah.
If I can add to that, I read on Twitter the other day that a 1% decrease in our water quality would lose thousands of jobs, and it could actually affect our GDP in the end. So, yeah.
Absolutely. Yeah.
Okay, great. Thanks. And question 4 was reducing non-revenue water losses has been made a national priority through government's No Drop campaign. Leaking pipes are often pointed to as the biggest culprit, but how important is the role that metering plays in this picture?
Absolutely, yeah. It's vital to managing water losses. Oftentimes water losses are perceived as water running down the street. And yes, that's true, but it's a component thereof. So if we look at the water balance, your non-revenue water or your water losses are referred to as either physical losses, so that refers to leaking pipes, burst pipes, as well as the apparent losses. So that looks at illegal connections, unmetered customers, or data inaccuracies within the metering life cycle. So whatever on the water balance, the way we interpret water losses, whatever's not metered is lost. So as you meter customers, you're having a direct reduction in your water losses holistically. And then also on a consumer level, by installing meters, you're creating awareness about the usage patterns of the customer. So they can immediately identify when their water consumption is increasing and take action to reduce it or mitigate their water consumption through water efficient fittings, etc.
So if a consumer can monitor their water use, then they tend to act on that, and then
yeah, absolutely.
So having some kind of display technology interface assists with the demand side management process.
Yeah, that could be important depending on the customer type and I guess capacity to take action. Again, I think those are important to take into account. But again, if we look at the whole distribution network of the municipality, by putting in meters within their network, they can also, just like customers, take action on smaller areas of their network and prioritize reduction programs, whether on apparent losses or on physical losses, where they have the capacity to take change.
There's a name for those demarcated areas, isn't there? Do you remember?
They're DMAs.
DMAs.
Discrete metered areas.
Discrete metered areas. Okay, great.
And it's been used globally, and it's very efficient in managing the water infrastructure.
Okay, thanks. Okay, and my next question is automated meter reading, or AMR, has emerged as a major trend for making the metering process more accurate and convenient for utilities and accessible for end users. Is this technology more suited to urban or rural environments, and what's the alternative?
Yeah, sure. Automatic meter reading is an important component in metering. the meter life cycle. Technology has disrupted so many different areas of society and industry. I think it's very valuable in the sector, but it depends on the customer types. What type of customers are you providing automatic meter reading to? And it depends on the capacity and capability of the Water Service Authority. So if they have dedicated resources to manage the data that's coming out, if they have the capacity to not get overloaded with all this data that can come out. The benefits of automatic meter reading are really to provide the Water Service Authority with access to customer consumption at very small intervals, whether it's a day, a week, or an hour. So it provides that type of interface, but doing this over hundreds of or thousands of customers can be a massive task to undertake.
I just want to take a step back, because some of our watchers might not know what automated meter reading is. Can you just...
Sure. So automatic meter reading, as the name suggests, is about using technology to capture the meter readings directly from the meter, and then sending that through to a centralized database or billing system, either through the use of a wireless network or a mobile data connection, or even wired connections in some cases. And so for the device to work, or the automatic meter reading to actually be reflected on the bill, you need to have that supporting infrastructure in place. So instead of sending out a meter reader, you just log on to the system and read and request the latest reading from the meter.
Okay,
directly.
do you know what networks those signals carry on in South Africa?
So yeah, they can either be like typically they set up as a mesh network, so it could be a small wireless network, either Bluetooth or a low range connections, or it can be directly, and those small networks are then sent through a GSM based network. It doesn't it's not very data intensive, so it doesn't need the fastest network,
The higher, yeah.
but it does require some form of communication. Some meters do send the data directly through a little a data connection or SIM card, either GSM. I know they're piloting NB-IoT connectivity as well in the metering space, and there's different protocols also available, proprietary stuff.
Okay, and then so are you saying that if we're looking at the urban-rural divide, it's not a matter of urban-rural, it's what type of user community you have, DMA? Okay.
Absolutely, yeah. I would say that connectivity, mobile connectivity is better in urban areas, and the philosophy has typically been the denser, the more appropriate AMR is. But I would say that ultimately it comes down to the capacity and capability of the Water Service Authority and the customers. Automatic meter reading only takes into account improving the meter reading integrity. So it doesn't necessarily look at whether the customers are paying for the water services or anything downstream from the meter reading. And if that reading isn't integrated into the billing system, then a lot of that value is lost within the AMR system.
Okay.
So you really have to take a holistic approach.
I know Ekurhuleni a few years ago implemented a system where they got their business industrial areas, they prioritized them for their water demand management program. So that, I think maybe that would be an ideal case perhaps for AMR, because you have businesses who all rely on wireless networks to get what they need to do done, and then they're also, as large consumers, they're in a better position to monitor their own leaks and their own usage and see a financial benefit for themselves.
Absolutely.
So they had some success there using that. I'm not sure if they used AMR, but they definitely focused on their metering for that.
Yeah, part of the metering cycle is just making sure that the data is correct on site. So especially in Ekurhuleni there, they prioritized consolidating customer meters so that each customer had one or as few meter connections as possible, preferably one meter connection. But yeah, it comes down to a return on investment, a business case, and what makes sense for the municipality or the water service authority.
Okay, thanks. Okay, and my next question is, what is water balance reporting and why is it important?
Cool, that's a great question. The International Water Association put together, through their team of experts, put together a report called the Water Balance, which looks at the entire water value chain, and it looks at how much water the water service authority is losing at the end of the day. We refer to that as non-revenue water, and so what it does is it breaks down that non-revenue water into something that can be tangibly managed. So for your non-revenue water, it looks at your physical losses, it looks at your apparent losses, but then in your apparent losses it breaks it down and quantifies how much of it is due to illegal connections, or how much of it is due to data inaccuracy or unmetered connections. So that breakdown provides the Water Service Authority with an opportunity to engage between departments. Water is typically managed through the technical department, so your water unit, which is doing operation and maintenance and fixing pipes, as well as the financial department, which is typically responsible for managing the meters, so the billing, the reading, the collections. And oftentimes when you refer to a water loss, it's seen as a technical thing. So the technical department is mandated to go and reduce the non-revenue water, when actually it's a partnership. It's an interdepartment thing that has to be managed, and the water balance makes it quite clear, or tries to quantify where the responsibility lies. And we found that it's an excellent tool for engaging between departments, and it just opens the conversation and provides the managers with a tool to be able to dig deeper into specifics, to be able to identify what is the best approach that we should take to reduce our losses. It's also useful for really incorporating other information, such as the billing system information, the call center information, as well as GIS information. By integrating all of that into the water balance, it creates a clear picture of where the Water Service Authority is. And for water service authorities that really want to reduce their non-revenue water, it's important to lay everything on the table, integrate it, and work from there, take steps to work from there.
So municipalities do need to report on their non-revenue water. So is this a tool which they can use to help them do that more accurately and more concisely?
I would say that the reporting that's required at the moment is from a financial perspective. So they'd look at their water sales, and they'd look at their water purchases, or the water that they treat, and the difference is seen as water loss. And unfortunately, National Treasury has referred to it as a water loss and not a non-revenue water, because it makes it sound like it's water that's running down the street. So for me, the water balance provides the Water Service Authority with a tool to reduce their non-revenue water and action items from there. So it has to be a continuous discussion.
Okay, thanks very much. And next question is, when do you implement pressure management for certain areas for the DMAs? And what are the risks to underground infrastructure? How do you manage these risks? Obviously, we all know the feeling, you expect a certain pressure to come out of your tap and it doesn't. And I'm just curious how that affects your valves, your pumps, your pipes underground.
Sure. So internationally, pressure management has shown its benefits in reducing water losses, physical water losses. So as your pressure reduces, your bursts and your pipe pipe leaks reduce, and it's globally understood the benefits of pressure management. Typically, but that being said, pressure management is about reducing the pressure in the network, so keeping it within like the required upper limits of the pressure in the network, and then keeping it above the minimum pressure in the network.
So the networks are specified with so that they are able to cope with these changes in pressure.
Absolutely, yeah. But customers expect a level of pressure within the network. So whenever you go in and create a pressure managed area, if we can refer to it as that, it's going to bring change to the entire network as well. So what we'd typically do is we'd start off by modeling the network, develop a hydraulic water distribution network model, and then understand what the network is, how the network is currently acting. It's no use to just go and install pressure managing devices throughout the network when they're not required. So we're going to engineer and optimize where these should be installed, and then you're going to require like a pressure reducing valve, some boundary valves to close off the area and ensure that the pressure actually is reduced, and then making sure that through the model you can see what type of changes would occur if you were to reduce the pressure. Are you going to still meet the required pressure within the distribution network? So that's important. And then we go out and we physically monitor that, install data loggers, measure the flow and the pressure within the distribution network.
So what would be the typical scenarios where you do pressure management?
Yeah. Sorry. So the areas would be where there's a reservoir that's serving an area that's got quite a few hills and valleys. So the reservoir has to at least provide a minimum pressure to the highest point within the network, but then the low areas within the network see incredibly high pressures, or can see incredibly high pressures.
Because the gravity causes the pressure to increase?
Correct, yes, yeah. So we'd go into those areas and identify what type of requirements are there based on the characteristics of the network and the customers, and then create these pressure management areas where the pressure can be managed.
But also where drought becomes critical, can you implement steps as a response, pressure management steps as a response, or is it too, by the time it's, you know that your reservoir's run down, is it too late?
Yeah, I think that's too late.
Okay.
Already, yeah. So what pressure management, your pressure reducing valves are going to do is they're going to reduce the maximum pressure within the network. So it's not like it's closing the pipelines to those low-lying areas, but the water's gravity fed and it's going to go to those low-lying areas first. So it's not a tool to mitigate
Drought, it's a long-term demand management strategy.
Correct, yeah. So what you want to do is you want to minimize the pressure differentials, the pressure spikes within the network, because those pressure spikes can severely affect the infrastructure that's in place, and it over time creates burst pipes and leaks. So you really want to manage the pressure so that your infrastructure can last design life and more. Yeah.
Okay, so this is also a way to extend the life of your existing infrastructure,
Absolutely.
which we need as we've come to our 50-year replacement time in the cycle for pipes, and if municipalities don't want to spend huge amounts on replacing all their pipes, this is a way they can get a bit more.
Yes, absolutely.
Okay, and for my next question, how can engineers assist government in its war on leaks while still creating jobs for local labourers?
Sure. The War on Leaks program is a national program that was rolled out a couple of years ago, and very ambitious, creating thousands of jobs.
It was 15,000 over 3 years.
Over 3 years for artisans, plumbers in the water sector, and the main aim is to fight on property leaks. So looking at government institutions, schools, hospitals, and low-income areas where people cannot replace leaking taps or toilets. So it's an ambitious endeavour, but I think where engineers can add value is in identifying areas where the program would be most appropriate, so in the planning stages of it, and then also in developing standard operating procedures for the water service authorities where these plumbers would be based, so that there's not just the training that happens, but also the continued checkup and monitoring that can take place for these.
So benchmarking success, so that
correct.
You can continue to build on that success, so that you realise that there is economic upliftment as a result.
Absolutely, and I think the intention is then to increase it and roll it out further. And without the data and without the performance management thereof, there's no basis for rolling it out. The other aspect I think that's quite important is in the management of the local labourers. That is an intensive job, and it requires managing not only the labourers' time, but also the tools, the supplies, and so that they can do their job as best they can.
So it's a human resources function where engineers and engineering companies will have experience managing those particular types of human resources in a way that that a straight human resources management company wouldn't.
Correct, yeah. So, I mean, government's rolled out a lot of local-based labour-intensive programs, award-based programs in different government sectors, the EPWP program in the infrastructure sector, and we've just seen how important it is to actually manage those labourers, local labourers, to be able to report back again to obtain funding for the next financial year. So that management reporting is very, very important.
Okay, so this is so that it's not a flash in the pan, so that it's an ongoing thing that continues building on itself.
Okay. Yeah, I think it's important to differentiate between job creation and
work creation.
Work creation. And I think the ultimate goal has to be long-term, it has to be sustainable, and it has to be really about empowering the local community. I mean, our slogan is global experience, local people, and I think that's where we have to, how government has to approach this too, by using the global engineering experience within the water sector, managing the local people.
Okay, so obviously Smec having the global ambit, you've got that experience to draw on. You've seen it happen, or your engineers have seen it happen elsewhere in the world, and you can see how to grow this program.
Absolutely, yeah.
Okay, great, thanks. And what is the difference between proactive and reactive water demand management?
Yeah, for me, proactive water demand management means that the Water Service Authority has a strategy or a business plan in place that they're working from. So it's about understanding the risks in the distribution network, in the water value chain, and putting measures in place to mitigate those risks, and then having sufficient resources, staff, tools, equipment available to actually implement that business plan, as well as the capital and the budget allocated to actually manage it. I think those are the key components of proactive water demand management. Some examples of that would be where municipalities have implemented strategies and have allocated that onto their IDPs, and they have to report on that and show that they are actually reducing their non-revenue water in their sectors. And it's also about, through the water balance, integrating the different data sets, so making use of the valuable information that the utility is gathering on a monthly basis from the billing system, the call center, the GIS, integrating those together, having the different departments take ownership for their responsibilities whilst being aware of what the other departments are doing. think those are signs of proactive water demand management.
Yes, because there are those municipalities that just buy a whole lot of product towards the end of their financial reporting cycle, and they try to show that yes, we've spent our allocated budget, we've checked the box, but they're not solving a
Sure.
problem.
Sure.
So you're saying that it's not even about problem solving, it's about understanding that we are a water stressed country and then accepting that and managing it from a starting point and making that a continuous.
Absolutely. I think the biggest problem but also opportunity at the moment is that water demand management and not is a compliance-based program at the moment. Non-revenue water has to be reported on monthly, has to be reported on annually, and so it's people do it out of a compliance need. But for me, proactive water demand management is cognizant of compliance, but actually implements it and develops solutions to reduce their water demands. Yeah. In terms of reactive water demand management, for me, that's the symptoms are where municipalities are spending their operational budgets early in the financial year, and they run out of budgets to actually do repairs and maintenance. They're not integrating their different data sets. The different departments don't know what they're doing, what the problems are, what the opportunities are, and where there are overlaps in their service offerings. And I think the outcomes are that the staff are frustrated. They get frustrated because people in government want to do the best that they can do. They want to provide services, but when there's it's not just red tape, but it's technical red tape as well as financial red tape.
It sounds like siloed information.
Yeah, it's very difficult to actually do the best you can do, and I think for me, those are the symptoms of reactive.
Okay.
And we can often feel like a headless chicken type of approach where through the water value chain you go and you target infrastructure, but because you're not looking at the source or you're not looking at the customers, you're not seeing the value that you initially expected to see through developing or replacing this. Oftentimes, if you don't have the engineering designs or the overall view of the system, you can go and repair pipe hundreds of times without knowing that the reason it's breaking the whole time is because of a design flaw. Maybe you need to install pressure management, maybe you need a bigger class pipe, maybe you need a smaller pipe. So it's definitely taking a holistic approach to the water infrastructure and not just looking at it on a case-by-case basis.
Okay, so regarding revenue enhancement, I think a lot of municipalities think if they institute demand-side management, there will be an immediate boost in the revenues. Is that always the case, or what are realistic expectations?
So looking at water demand management, it is linked very closely with revenue enhancement, but it's important to note that if you're looking at physical loss reduction, so pressure management or pipe replacement, the infrastructure intensive programs, there you're going to be looking at reducing the water that you purchase. So that would be a savings more than a revenue enhancement. Okay. If you look at the apparent loss reduction programs, so whether it's on the meter, installing meters to customers where there are no meters, putting in management systems like DMAs, or just doing meter audits or database cleansing along the meter management life cycle. There you can also see revenue enhancement, but it's just installing a meter doesn't mean that you're going to get revenue from that meter. That meter has to go from there, go onto the billing system, be linked to the correct customer, and so that the meter reader, the next time they go out, they actually read that meter, and the bill gets generated and goes to the right customer. So if that process isn't taken into account, then the value or the proposed outcome of installing the meter won't be achieved. So you won't see the revenue enhancement.
Okay. And there was a report released a few years ago which broke down the statistics of our non-revenue water losses in South Africa, and I think it was about 24% then. That was not all municipalities provided data for that. Do you have any more recent data on what the picture looks like in South Africa, and how does that compare to overseas?
So, I mean, it's a mixed bag throughout South Africa. Each municipality's got different indicators or different ways of reporting their non-revenue water. I think the most robust one is using the billing systems. How much water are you buying, and how much water are you selling to your customers? But what we found is that oftentimes municipalities don't know how much water they're buying, purchasing. So if they're treating the water on site at their water treatment works, their meters may not be working, or there may be problems in getting that data through to the billing system, so it's not reported there. And then likewise, as you diversify your metering from conventional metering, so you start using automatic meter reading or prepaid meters, that may not get onto the billing system, so that then again skews your non-revenue water figures. But I'd estimate that it's between 35 to 50% non-revenue water. I've seen it go as high as about 75%, and I don't think that's
normal. No.
Yeah, but I don't think that it's also that abnormal either. I think the way I perceive it is understand what your losses are and then work from there. I think when you report your non-revenue water as a percentage or as a volume, people immediately shy away and try to act as good as they can, or try to make it look as nice as they can. But for me, it's not about that figure. For me, it's about the next figure. So what's it going to look like in a month or in a year?
You're not checking boxes, you're benchmarking and improving.
Absolutely. So I believe as a civil engineer, our mandate is to serve South Africa and to really enhance the industry for future generations to come. And I believe that one indicator now doesn't define the Water Service Authority, but it enables them to put steps in place to become better at what they do and be more efficient. And ultimately it's about increasing efficiencies and reducing fruitless expenditure.
And finally, what are the lessons learned from the drought which continues to affect Southern Africa's coastal areas?
So on a social level, I think the two things that I'd like to highlight are just that people do change behaviors. I think in Cape Town over the last 6 months we've seen customers reduce their demand considerably based on the requirements from the Water Service Authority. I think that speaks of how important communication is between the Water Service Authority, being transparent about the capabilities, the operations of the water value chain, and allowing customers to be part of that change. So with the Water Service Authority working towards continuous supply again, I think it's important to include customers within the entire design process so that they can take ownership thereof. I think that's a broad brush, and people may not partake in that necessarily and may be resistant to it and feel like they're paying for the service. They should be getting it. But the reality is climate change is going to have a significant impact on the water sector in South Africa, which requires a partnership from government, industry and customers at the end of the day.
Okay, well then can I just add another question to that, which is, as an engineering firm, I'm sure you're very familiar with the technological changes that have to happen at service provider level. But how do you partake in that behavioral change that needs to happen?
So again, water is interdepartmental in government, and oftentimes there is this siloed approach. So as technology exposes the infrastructure and gives them a voice, it's easy to hide behind the lack of information. So people would be resistant to releasing that information to different departments to make them look good. And I think it's a very political type of setup. Water can be very politically driven, and it's important to make use of technology at every level that's available. Use what's available in the market, and let that enable the business to run the Water Service Authority. And I think the technology will become much more accessible, especially with the Internet of Things, with mobile data that's becoming cheaper and cheaper, and with sensors becoming cheaper. I think we're looking at a potential revolution in the entire infrastructure sector, and water will be part of that.
So you're saying the technology drives the behavioral change because of the way the technology is changing?
Absolutely. I think as people are exposed to the understanding of the level of the dams or the reservoirs or the network and the changes that have taken place, that will definitely impact the way that people interact with the Water Service Authority at the end of the day.
Okay, brilliant. Thank you so much.
Sure.
Okay, signing off, this is Francis Ringwood and Dr. Pieter Crous of Smec South Africa. This has been Infrastructure News' CPD on Demand.